Here we will be determining the antiderivative of the following problems. Our first problem is the integral of 2x plus 6x to the fourth minus 8x to the fifth over x cubed dx. So the first step in completing this problem would be to move x cubed up to the top by making the exponent negative. So then we get the integral of 2x plus 6x to the fourth minus 8x to the fifth all times x to the negative 3 dx. And so now we must distribute x to the negative 3, which gives us the integral of 2x to the negative 2 plus 6x minus 8x squared dx. So now all we have to do is solve the antiderivative. So all we have to do is add 1 to the exponent and then divide by the new exponent. So we get negative 2x to the negative 1 plus 3x squared minus 8/3 x cubed plus c. And since this is an indefinite integral, c represents the unknown value. The next problem is the integral of 3x plus 2 times x minus 3 dx. And so the first step in completing this is multiplying it out. So then we're going to get the integral of 3x squared minus 7x minus 6 dx. And so now we're just going to solve for the antiderivative by adding 1 to the exponent and dividing by the new exponent. So we get x to the third minus 7 halves x squared minus 6x plus c. The next problem is the integral of 4 over the cubed root of x squared minus 6 times the fifth root of x dx. So our first step in completing this is changing the roots into the fractional exponent. So we get the integral of 4x to the negative 2/3 minus 6x to the 1/5 dx, and we do this so that it's possible to add 1 to the exponent when we are trying to determine the antiderivative. So that is our next step, is just to add 1 to the exponent, and divide by the new exponent. So we get 12x to the 1/3 minus 5x to the 6/5 plus c. The next problem is the integral of 4/3 x squared times the fourth root of x cubed dx. So in order to do this, we have to change the root into a fractional exponent, and then multiply it by x squared. So we get 4/3 x to the 11/4 dx. So then we're going to add 1 to the exponent and divide by the new exponent. So we get 4/3 times 4/15 x to the 15/4 plus c. So then simplified, that would be 16/45 x to the 15/4 plus c. The next problem is the integral of cosine x plus secant squared x dx. And this antiderivative is just taking the integral of these, and you get sine of x plus tan of x plus c. The next problem is the integral of theta to the negative 3 plus 9 cosecant squared of 3 theta d theta. And all you have to do to solve this is add 1 to the exponent and then divide by the new exponent. And to take the antiderivative of 9 cosecant squared 3 theta, you just have to know the rules for it. So cosecant squared theta is always cotan theta. So then to get that, you just take the antiderivative of that, and you are left with negative 3 cotan 3 theta. So then your whole answer would be negative 1/2 theta to the negative 2 minus 3 cotan 3 theta plus c.